Hello everyone. Welcome to the SciEd School. Today, we will learn the OSPF, Open Shortest Path First, concepts. OSPF, Open Shortest Path First. It is a link state routing protocol, meaning that each router in the network maintains a complete map of the network topology. This allows OSPF to quickly recalculate routes when there are changes in the network, such as a link failure or a new router being added. OSPF is a popular routing protocol for large networks because it is efficient and scalable. It is also reliable, as it can quickly recover from network failures. The routers together build a lot of information about the network like routers, links, IP addresses, status information, and so on. Then, the routers flood the information, so all routers know the same information. How OSPF organizes the topology information. It uses LSA, Link State Advertisement, and LSDB, Link State Database. LSA is a data structure with specific information about the network topology. LSDB is a collection of LSA. What does OSPF routers do with LSAs? OSPF router make their own LSA which consist of its router ID, connected subnets, interfaces, if the state of interface is up or down, cost to subnet. OSPF router floods the LSAs, so that each router have the same number of LSAs in their LSDB. However, routers ask the neighboring router if they already have that LSA before sending it. This prevents infinite flooding. Consider router 4 in this topology. R4 creates its LSA and forwards it to its OSPF neighbors, and they forward to their neighbors. This forwarding ends when all the routers have router 4 LSA. Similarly, every router makes LSA and forwards. At the end, LSDB will have 5 LSAs and the routing algorithm will decide the routes based on the metrics. LSA gets reflooded when some information changes, like if the link goes down. They also reflood each LSA based on each LSA's separate aging timer, default 30 minutes. Once every router have the same LSDB, who calculates the routes and updates the routing table. It is the routing algorithm which is Dijkstra Shortest Path First, SPF, algorithm for OSPF. 3 phases of OSPF. Becoming neighbors, only directly connected OSPF router are neighbors. They exchange OSPF messages like hello messages and becomes neighbor if compatible. 2. Exchanging databases. Once becoming neighbor, routers exchange LSDB. 3. Adding the best route. Once LSDB is complete, SPF algorithm add the routes to the routing table based on OSPF metrics. SPF considers only the outgoing port cost in a route path. Designated router and backup designated router. If more than 2 routers are on the same Ethernet link or VLAN, OSPF makes one router as designated router, DR, and one router as backup designated router, BDR. BDR takes the position of DR if DR fails and a new BDR is selected. LSA exchange does not happen between every router on VLAN, rather DR exchanges LSDB with every other router using SPF multicast address. Routers other than DR and BDR are known as DR others, and they use multicast address to send messages to both DR and BDR at once. Since DR others do not exchange LSAs with each other, they are known as neighbors, two-way state. The command show IP OSPF neighbor on DR other will show full state, fully adjacent neighbor, for DR and BDR only. In the rest, routers on VLAN will be shown as two-way state. We see 4 routers connected to a switch or VLAN. OSPF makes one DR and one BDR here. Router 1 is not connected to this VLAN and does not come into this consideration. OSPF areas and Y areas. OSPF areas are subdomains within an OSPF autonomous system, AS, that help divide a large network into smaller, more manageable segments. This division offers several benefits. Suppose we use 1,000 routers in an organization, which leads to huge LSDB, and all the 1,000 routers need to start SPF again to update the routing table if one router link fails. CPU takes a lot of time to calculate new routes using SPF, and the network convergence will take a lot of time. What if we divide 1000 routers into areas? This will make a smaller LSDB per area. Area 1 LSDB will have the topology of Area 1 only. If one link fails in Area 1, SPF runs again only in Area 1. This makes the network convergence faster. We make Area 0 as backbone area. All other areas must connect to this area via ABR, Area Border Router. ABR are the routers which connects backbone area with other area. All the routers have routes to subnets in other areas via ABR. This route is called inter-area route. However, routers does not have the LSDB of other areas. We use single area in CCNA level. Multiple areas OSPF will be used in CCNP level. We have divided the network into 3 areas here. One is backbone area, Area 0, other is Area 1, and the third area is Area 2. We have just taken one router into Area 1 and 2 for simplicity. Router 3 and 4 connects non-backbone area to backbone area. They are called ABR, Area Border Router. All 3 areas LSDB are different and short when compared to single area LSDB. Area 1 router can connect to any router here via ABR. Area 1 router LSDB have information about all the subnets in the other areas in simpler form, as it just needs to forward the other area subnet traffic to ABR.